I actually took an early version of this back in 1981 when I was a student, when it was EDG 105, and we carried around a box of pencils and straight edges and erasers, and we did it all by hand. So this is a very useful class for ag system students to take, even though, you know, it's kind of an engineering drawing class. We expect you to be able to draw and communicate your ideas professionally using the drawing tools that are available to you. So, you know, this is part of the communication process. There's written communication and oral communication. And so being able to draw and draw well in a way that that looks professional and communicates your ideas to people is fundamental to that. So with that, I'd like to welcome Mr. Whiteacre. Thank you, Matt, for coming. Let's give him a hand for being our guest lecturer. You can only hear me.
You're welcome.
Does it one at a time. So it's over to you.
Very good. If you had it in 81, I'm about 3 years ahead of you because I had it in 78. I took EDG 105 and 106 back in 1978, 79 years. So
it was.
It's been a little while.
It was over. It's the anthropology building now. It's right next to Scoats Hall. It was up on the second or third or fourth floors up there. These big rooms with huge drafting tables. We'd go in and we'd lay out our paper, and you'd draw a nut or a bolt, and you'd have to get the threads right, and all sorts of fun tasks.
Yes, you don't know what you're missing with computers. It's interesting. Anyway, very good. Well, what I want to do today, Colonel McGee asked me to come in and just kind of give you a quick review. Depending on how long ago you had me in 105, we have transitioned from teaching AutoCAD, which is what we used to teach, into teaching 3D solid modeling with Fusion. And we had a little debate amongst us as to what would be a better thing to review and what would go on. We've decided we're going to talk about 3D solid modeling because it's probably more applicable in general to making basic drawings, basic illustrations, those types of things, right? For some of you, this is going to be just a nice quick review, especially if you just recently had the course. If you had it a while back and you've never seen Fusion before, this is going to be a fire hose type of a presentation. I'll be real honest with you. We have an hour and 15 minutes to go through the basics of what's going on. I don't intend on trying to teach you every little detail of Fusion. And when I go into Fusion and I'm drawing things, I'm not going to try to go slow enough that everybody can literally keep up with me in real time. The class is being recorded. You can pull it up afterward, go through it, pause, catch up, pause, catch up, pause. And so I think we'll be fine on getting that taken care of. But there are just a few things that I kind of want to go through and give you an idea of what's happening. So with that, I'm going to go ahead and share my screen where I can get into PowerPoint. Oops. And go back to the first of the presentation. Come on. There we go. So again, just a quick introduction or review, depending on where you are in the state of things, as to what's going on with solid modeling and how we approach that in Fusion. One of the things that Fusion has, one of its basic advantages, is that it's probably one of the most straightforward programs just to learn how to use. It also runs both natively on Mac and PC, so you don't have to worry about that. With any solid modeling program, I don't care whether you're using Fusion, Inventor, SolidWorks, whatever in the world else you might have run into, there are basically four methods of putting things together. Either you start off with this block T and just stretch it out straight, which is an extrude. You take it and swing it around an axis to make a revolve. You take it and let it follow a path to sweep things out. Or if you have two different shapes, you want to go from a block T to, in this case, a circle, you can use a loft function. Probably that's in order of frequency that you run into things. Lofts are really useful when you need them, but there are not a lot of parts in the engineering world, at least, that require lofting. Airplane wings, boat hulls, things like that that are defined by cross sections are your most common application for that. The way it works, you're going to start off in Fusion and you're going to draw that block T, whatever it is. You're going to draw a two-dimensional sketch and then constrain and dimension that so that everything comes up the right size. All right. So it's a process of identifying this sketch, dimensioning it, constraining it, converting it to 3D, and then just building on from there, right? Adding more extrudes, revolves, drilling holes, filleting corners, whatever it may be. Right? So when you first start off in Fusion, you're going to look at what you're trying to draw and you're going to say, where do I want to start drawing this thing? Because I'm going to start with that two-dimensional shape and then extrude, revolve, sweep, or loft it. So where's the best place to start? And the answer is not always absolutely identifiable. It's not unique. If I were tasked with drawing that part there on the left, I personally think I would start with this view here where I highlighted it with the blue and then proceed to extrude it going back along the axis. Someone else might look at it and say, well, I'd start with a rectangle from the top and extrude it up and start building upward. Fine. There's not necessarily a right answer. There are sometimes easier answers and sometimes harder answers. But there are a lot of different ways one could get to this final part. It's just a matter of how quickly could you do it and how easy it is to modify later on. The two belt pulley there in the middle, obviously you're going to want to do a revolve on that. Could you do a sweep? Sure. Could you do a loft? You'd be stretching it a little bit to do a loft, but in theory, I could set it up that way. The part over on the far right, whether you start from the top, drawing that kind of tombstone-like shape, and then extrude upward and then machine out the rest of the stuff, or I could start on the front and then proceed to round things off. Whatever you're going to do, you're going to look at a part and say, here's where I want to start. And just keep that in mind and start and work with it, right? When you get into Fusion, the first thing you're going to want to do is to start putting a sketch together, right? If we go over to Fusion, how far down is Fusion? There. If we go over into Fusion, the first thing I'm going to want to do is to put a basic sketch. So I create a sketch. This is the launching point for pretty much everything that you're going to do. You can choose what surface you want to start on. Fusion will allow you to sketch on any planar surface that exists in your design. Right now, there are 3 of them, right? The frontal, the profile, and the horizontal. And I can pick any one of those 3 to sketch on to do my initial sketch. Then I've got to stop and think about, well, what is it I'm trying to sketch? Because my sketch is just going to be a 2D representation. So if I'm looking at this object, a nice simple kind of U-shaped bracket with a hole in the back, all right? First thing, hopefully everybody that had my 105 class could go through and figure out what this thing looks like in 3D, all right? You should be able to take a couple of minutes. I'm not sure I'm going to pause for 3, but to remember what this thing looks like as you go out into 3D and they're starting to look at what's going on. I mean, basically, it's got that kind of a top. That kind of a shape. With a hole in the back of it, all right? Hopefully that's not a shock or a surprise to anybody. You should all have had 105 and understand the basics of orthographic projection. So the question is, how are we going to get Fusion to generate that thing? right? So we look at this and say, well, where's the best place to start? In my opinion, the best place is the top view, right? So we're going to start off and look at that U-shaped region there in the top, drawing that thing out with those dimensions. So we go over diffusion. We're going to start a sketch on the horizontal, the top, right? Then we're going to draw lines that are depicting that basic shape. And you notice I'm not trying to be real careful to make sure I drew it the right size. That frustrates some people no end. But the way a parametric solid modeling program works, once I get the basic shape, you'll see some of the lines are still blue. Those are not well defined. I can add dimensions and say, well, gee, this thing was supposed to be 1.5. Now it knows where that top line is. This was supposed to be 0.5. This was supposed to be 0.5. From there to there was supposed to be 0.5. And the overall size right there was supposed to be 3. It looks like it's all well-defined, everything is happy, and you know exactly how big it is, and you check for things, and all of a sudden you notice there's this one blue line down here, because no one told it where that had to line up. I can either go in and put another dimension on this side, oops, and define that also as 1.5. Or I can come in here to my little section called constraints and tell Fusion that I want 2 lines to be on a line with one another, collinear between this one and this one. So they'll all line up at all times. That gives me a basic sketch. It's just a U shape, 1.5 by 3 with 1/2 inch edges. Once I've got that sketch done and I'm finished with it, I will finish my sketch. My operations for turning things into 3D objects, there's extrude, there's revolve. Others exist underneath here. If you drop that down, there you can get sweep, loft, rib, web, etc. But if I just say extrude, bring that thing up 2 inches, drag y'all's pretty little pictures out of the way where I can see what I'm doing, and say, okay, I've got the basic structure of that U shape. I say, well, okay, that's taken care of. Now I want to drill a hole. There is an actual tool to make holes. For the moment, I'm going to skip over that and just do this as a second sketch. I'm going to create a secondary sketch. I could use any of those 3 standard surfaces or any of the existing surfaces in my object. I want to use the back of this block. I want to draw a circle on the back edge, dimension it at diameter 1, from one edge to here should be 1.5, from the bottom to the circle should be 1, and I've now centered that on that back face. It's black, everything is well defined. I finish that sketch. I extrude that circle. If I were making a post to stick out of it, I'd bring it out this way. If it's to be a hole, I bring it out the other direction. Fusion is generally smart enough to know which one you mean. If for some reason it gets confused, I can change the operation from cut to join and turn it into a post if necessary. And then say OK. And that's your basic object. That's your first drawing in Fusion. Fusion makes it very easy to go in and do things. If I take a second and kind of look around, on my left here, I've got what's called the browser. Each thing that I sketched shows up as a separate entity on the browser. So if someone came in and said, hey, that 1-inch hole was supposed to have been 1 1/4, if I double click on sketch 2, I can double click on my dimension and it enlarges the hole. If someone comes back and says, well, gee, it was supposed to have been 2 inches deep instead of 1 or 1 1/2, I can change that. I have access to all those dimensions. So later on, when someone comes and says, you know, you got that wrong, you don't have to say friendly words under your breath about them. You can just say, oh, fine, I'll take care of it, right? So all we're doing is going through, putting our drawing together, letting Fusion concede some of the things, perpendiculars, it makes some basic assumptions, going in there, extruding it, drawing the circle, cutting it out, etc. That's your first part in Fusion, right? That's how Fusion works. Right? If you want to interrupt, I vaguely watch the chat, but I have no objection to someone unmuting and saying, Mr. Whiteacre, could you? And so if you want to, feel free to interrupt me. You will figure out, you all are, this is a 400 level class, so you all have been here a while. You understand the concept. If you let a professor get up ahead of steam, you'll never get a word in edgewise. So feel free to try to interrupt me if I lose you somewhere.
So Matt, how would you display the dimensions on that? I mean, that's a beautiful drawing. If they want to display that with the dimensions shown, how would they do that?
That's about 10 or 12 slides down the presentation.
Excellent.
So if you'll hold the question, I've got the answer to that. You have to go into a separate mode and create a drawing of it. So, but yeah. Right. Oh, it's not even 10 or 12. It's like next, drawings from 3D models. I thought I had one more example in here. But as Colonel McGee says, you know, how would you actually turn this into something that's useful for a drawing? Right? If you've got this thing built in 3D, but you want to actually put it on a sheet of paper, which is 2D, I suppose you can always do a screen capture of that object and paste it in a Word document and make a pretty picture. But that's not really a technical drawing, and it doesn't really show you the dimensions and all that good stuff. So we talk about creating drawings of it, right? There is a whole separate mode to create drawings. Right? Once I've got my part modeled, if I go into drawings, I have two choices. One is from the design space right here on screen, or if you notice there's an animation mode, if I have an assembly and I want to explode components, I can explode them and do an animation. We're not going to see that today. I just don't have time to get into that. But if I do from design, oh, it requires it be saved first. Save your part as something or other. Then it'll let you make a drawing of it. Right? Either what's visible, select what you want, or do the whole thing. It doesn't really matter. What standard do you want to use? ASME, American Society of Mechanical Engineers, is pretty much the American standard for how you're going to arrange top, front, right side views. ISO is the international standard. ASME uses third angle projection. ISO uses first angle projection. It depends on who your target audience is. I'm used to working ASME, so that's where I'm going to set it. What units do I want to use, and what size page do I want? 8.5 by 11, right, whatever. And say okay. And Fusion's going to buzz and whirl for a minute and think about it. Bring up a sheet of paper, draw a border with a title block on it. Bring your object up and say, where would you like to put this? If you go, well, I'd like it a little bigger, a scale of 1 to 1, or a little bit smaller, a scale of 1 to 4, I can control what scale this thing's going to be drawn at, where it's going to go, and then just say, okay. Fusion creates that view. A second view is a projected view. So I go into my projected view, I click the parent and say, all right, bring one up here, one over here, and a pictorial out there. And I made it bigger so it's not going to fit so nicely, but that's okay. Click the check mark or hit the enter key, and it will generate those views. Fusion is smart enough to know when something should be a hidden line, when something should be a visible line. It unfortunately assumes the pictorial drawing should also be visible and hidden, and that's not very much normal. So you probably want to right click and go into edit view, edit the pictorial and say, let's make that one shaded. Or if you like line drawings, we'll make it a line drawing, but don't show hidden edges. And since it's a pictorial, I really can scale it independent of the orthographics, and then everything fits. If you don't want to show your title block, sheet settings, the little eyeballs are always ons or offs. I can turn off my title block or on my title block. If you want a totally different title block, it's a bigger hassle. You've got to go in, create your title block, save it, and make a template. And so generally, if you're looking at illustrating things that you're likely to cut and paste into reports or PowerPoints or whatever, you can just totally get rid of the title block and not worry about it. You can also get rid of the border around it if you don't like that. I can drag the views around. It will never let them get out of place. To add the dimensions to it, there are a lot of times that the dimensions you use to build the object may not be the ones you'd like to display on the final version. So you're ending up doing sort of double duty. I'm redimensioning the object, saying, okay, from there to there is 2, from there to there is 0.5, there to there, 0.5, there to there, 0.5, corner to corner. And I'm just applying my dimensions one by one. The overall height of this thing. I can still reference the circle, either the quadrant or the center. If you're interested in changing the format of any of these, under document settings, I can control, do I display leading zeros? Do I display trailing zeros? To the far right of each of these is an edit, change display trailing zeros. And I can say, yes, display me trailing zeros. And now everything is at 2 decimal places. If you want to say, well, I really wanted it to be 3 decimal places, linear precision out to 3 decimal places. Technical drawings should have center lines on them. There are 2 different kinds of center lines, actually 3 if you count a bolt circle, but a standard center line, I pick one edge of the circle and the other, and Fusion will draw a center line down the middle. If I've already got a circle, it's not a center line, it's a center mark. I can pick my circle and Fusion will add center lines to it. Then I can create a PDF file, or I can create an AutoCAD file. Sometimes Fusion is a little sloppy in its drawings. It doesn't always draw center lines with dashes. It has other issues here and there. Why in the world one company, Autodesk, has the premier 2-dimensional drawing program in the world, AutoCAD, and they can't embed that drawing engine in their 3D program? I don't know, but they don't. So sometimes you have to save it out as AutoCAD format and then bring up AutoCAD and make final cleaning edits. I don't like it. That's the one reason I hemmed and hawed about teaching Fusion for a number of years. But they've gotten better, so I can do a lot of the edits here, so it's not so bad. If I go back to my drawing, design, I should say, and I go back and say, well, you know, that 1.5 is really what I wanted. Once I save this, if I go back over to my drawing, it'll have a little exclamation point up here in the top bar that says, hey, things are not in order with one another. If I click on that, it says, oh, all right, update my views. And it recognizes I changed that width or depth, and it updates it to 1.5. I can add, come on, radius, diameter, angular, or whatever. So if I want to give the diameter of the circle, I say diameter, circle, and put the diameter up there. Output a PDF file, open it once it's been output. Sure, save it there. And now I've got a PDF file of my drawing. Center lines, okay. Again, this is the whirlwind trip through Fusion, and I understand that. Anything I should talk about, go over, etc.
All right.
Okay.
Anybody have any questions?
So again, feel free to ask. That's a legitimate request. I'm not just saying that as lip service.
You may have went over it, but if you were to convert it from, say, inches to metric or metric to inches, what would you need to do that?
It depends on what question you're really asking. If your question is, oh, I didn't want to go to that one. I want to go to the Fusion. When you first drew this one, you messed up badly, and that was supposed to be in 1.5 millimeters by 3 millimeters. There is a sort of kind of cheesy workaround that you can, where is it, scale right there. You can scale an object up or down by 25.4. That's a cheap hack, and the problem is, if I do scale my drawing and then say, well, now I got to edit it, you got to worry about, are you editing into the new units or the old units, and you'll get terribly confused. If your question is, when I did my drawing, if my dimension units were set to millimeters, and so even though I said it was 3 inches wide, it says 76.2, then I just have to change this dimension units entry right there and change it over from inches to millimeters or vice versa. But that predicates on it having been drawn initially at the correct size. If you drew it in the wrong system of units, you're kind of hosed. It doesn't work real well. That's one you got to be careful about, because Fusion, if I'm editing this first sketch and I tell somebody that, hey, I want this to be 12 millimeters, Fusion's fine with letting you type out units. It'll default to, in this case, document settings are set to inches. If I want to set my document to something else, I can as the default unit, but I can always override it by typing things in. So if I wanted to make that 35 by 75, 12. When I save that, go over to my drawing, update my views, the inch numbers are going to look really weird. Come on. Update. Why did my computer lock up? I don't know why my computer decided not to redraw my object. Oh, because I didn't finish my sketch. You got to get out of the sketch mode, then save it, then update. But now if I change these units over to millimeters, they'll look nice numbers. I don't know if I beat it around the bush long enough to answer the question or not, but that's what you'd have to do. And again, I didn't edit all of these down here to be normal, just that view. Okay. All right. So what about assemblies? That was one pretty part, and it's nice and good and all that. But what if we're talking about putting together multiple parts to make an actual working mechanism? Right? Fusion, if you were looking at what it was doing a second ago, in the model over here, creates things called bodies, and a body is just simply a single chunk of material. Right? It by default always does that. But if you're starting to put assemblies together, bodies really don't assemble. I can kind of explain it, but it's kind of weird too. But there is another thing called a component, which is actually a container for a bunch of bodies that make up a single thingy. A ball bearing, it's got a bunch of spheres in it. It's got one side, it's got another side, but it's got multiple parts. A jet engine could be a component. It's got thousands of internal components. The trick is when you're putting together assemblies of multiple objects, each thing has to be a component. So when you do that, you have to tell Fusion, hey, I want to build a brand new component to put this thing together. So if I'm trying to do this object, right, just a nice, simple little two-piece clamp right here, it's going to have actually 5 components, or 6, I guess, because there are 2 nuts as well. But 2 components that you have to worry about drawing, and then we'll talk about importing the nuts and bolts. But I got 2 standard parts that I need to be able to draw. One's going to be called the upper saddle. One's going to be called the lower saddle. So if I go in and say, well, to do this thing, I need to be able to create those components. So I ask, well, let's start with upper thing, upper saddle, and draw that. So I'm going to go into Fusion, create a brand new drawing, put together a sketch on this surface. This one happens to be in millimeters, so I'm going to change my active units over to millimeters. And I'm going to put a circle on here. If you'll notice, as I get close to this line for the center, it locks on. And if I even slide it farther, it eventually kind of grabs the midpoint. And I get that little triangle showing there. That tells me Fusion has located the center of that circle at the exact center of that line. Now I can add my dimensions. I've got mine. Uh, 60. And I've got my dimensions on this thing drawn. Because that circle was centered, I don't have to worry about dimensioning it to be in the center. It just stays centered. I'm like, yeah, but you got extra lines and part of the circle, it's kind of ugly. If it really kills your soul, there is a trim function. The reality is no one cares, and sometimes extra geometry is useful. If I finish that sketch, say extrude, I can extrude this portion or this or this. So I can pick what piece I want to extrude and bring it forward. Just the basic shape of that upper saddle. It's got some holes drilled in the top of it. Put a sketch on the top. I should know by definition, using a constraint equal, that the 2 holes, click, click, are equal, and the 2 counter bores are equal. And I can add a horizontal so that those 2 centers stay directly in line with one another. Now it's just a matter of adding my dimensions. From there to there is 16. From there to there is 11. I cheat because I've got the drawing sitting right down there so I can look at it. From there to there is 11. This outer circle is 14. The inner circle is 10. just adding that information, it's now well defined. Since I told them these sides are equal, once I get sizes on one side, I've got sizes on the other side. But I have a problem. When I finish this sketch and I say extrude, I can indeed pick the two little ones and punch holes through. But it doesn't do anything with the big ones. So I've now got to use a two-step process. I'll punch those holes all the way through. And you're like, well, but I can't use my other circle. Well, you can. It's under sketches. I can turn this sketch back on again. And now I can extrude that little annulus and that little annulus downward -10. And I can turn off the sketch if it's annoying to look at it. That's my basic part. Problem being, I didn't make a component out of it. I didn't because most of the time people forget the first time. I do, however, have a body out of it. And if I right click, I can tell Fusion, hey, now that I've messed up and didn't do this ahead of time, let's create a component from this basic body. I now have component 1. I can slow double click on it. Call it upper saddle. I still have sketches 1 and 2. They're still available. But everything for that's contained in the upper saddle. Now, if I'd been doing this thing right to start with, I'd have gone up under the top. Actually, probably right now I should save this thing and call it, let's do it. Save it. If I right click, I can tell Fusion, start out with a new component, just right off the very beginning. We're going to call it lower saddle. Build that. Now my upper saddle grays out. I'm working on my lower saddle. I can put a sketch, but all of the upper saddle is still available. I can put a rectangle. Dimension the rectangle so that it's 20 tall. Do this geometric thingy saying collinear, saying I want things to line up and line up this edge with this edge. And now, should I go back and edit my upper saddle, my lower saddle will change too. If I turn back on my sketches, I can say, hey, let's project this circle from the other part into this part. So now when I do my extrude, if I edit something up here, the changes will apply to both parts. I can also go through and say, well, all right, I know I've got to drill some holes in here. Let me create a sketch on that plane right there in the middle. Once again, I'm going to project the little hole and the little hole. So now I've got those circles drawn. I can extrude, turn off the upper saddle, that piece and that piece out the bottom end. Turn back on my upper saddle, click the little radio button to the right of the main part, AGSM clamp. And if I go through and someone tells me, hey, you know that thing? It was supposed to have been 80 wide. I'm like, fine, it's 80 wide, top and bottom, everything lines up, everything's done. Right. Those holes were supposed to be 16 in. This thing should have been diameter 30. Everything updates and keeps everything balanced and in line with one another. Now I got my two basic parts. What about the other parts? What if I want to bring in my nuts and my bolts? Fusion has the ability to insert components from a company called Whiteacre. It's a really big parts manufacturer, seller, retailer, whatever. And they've made their entire catalog available to Autodesk for us to be able to import. And all you got to do is say, well, I'm looking for a socket head, hex head socket cap screws. One of these thingies. It's metric. It's an M8, metric thread, diameter 8. It's 40 some odd long. 45, probably 45 long. And you just say, all right, well, what exactly do you want? And eventually you go down and say, well, all right, this one looks good to me. Okay, slide over. When you click on the part number and go into product details, Fusion will let you insert that drawing, and usually step files work the best, but say save. And Fusion will go through and think about it for a second and come back and stick in your drawing that part eventually. There, it'll stick that part in your drawing. I can right click, copy that part, right click, paste that part, and I got two of them. They're not in the right place yet. We'll deal with that in a minute. Insert, McMaster-Carr. I just go nuts, hex nuts, metric, M8, Find which one you're interested in. Product details. Save as a 3D step. Okay. Right click, copy, right click, paste. And now it's just a matter of putting them all in the right spots. When you're working with things, each component is free to drag around wherever you want it to. If I capture position, it says, remember where I drug those to. If I say, hey, revert, it's going to put them back where they were. I like these two where I put them. I don't want to drag them apart. So I want to tell Fusion, take those and make a rigid group out of the upper and lower. Now I can't separate these two. These two are stuck together. If I also want to set it where they don't move around at all, I can right click on one of them and tell it I want to ground that part. Now I can't drag these at all. I can just drag these along. All right. To assemble them, I use things called joints. Joints take points on one item. Things. It says, all right, I want to take the center of that circle and put it at the center of that circle. Oh, and let's flip it upside down while I'm at it. I want to take the center of that circle, put it at the center of that circle. Oh, that one came up right side up. I want to take the center of that to the center of that. Flip that one. I want to take the center of that to the center of that. Now I've got an assembled working object. If I know that these bodies, oh, these are made of steel. If I know what material this is made out of, I can change the physical material and select from a bunch of things. Blue anodized aluminum. Red anodized aluminum. I know that's not what the part's called out as being. But I can change the material of these parts. I can scroll this around or whatever. My joints can be turned off where I don't have little blemishes on things. And now I've got something that is vaguely ready to screen grab and paste into a report if you're trying to talk about this particular clamp. Now, that's about 20 or 30 slides. Like I said, the PowerPoint slide is really, or presentation is really long, but a lot of it is what's going on here. All right. What I did with joints is I just made everything rigid. I didn't care. If you really want to let things have a little more motion to them to actually simulate things, I could easily have made this thing a cylindrical joint so that it will allow it to spin and move. So I can drag it up or I can spin it. So if I want to allow motion, I can do that. If I don't have to, but I can. Notice that I can't get it out of that hole. It's stuck in the hole. It's stuck on its axis, but it can slide and spin. And there are different options for how you can make things actually interact with one another. You can also do a rigid group, which is what I did on those two parts. Or I could have done an as-built joint. If you look over here in Fusion, there's an as-built joint. I could have done that since I built them literally on top of one another. As long as it's rigid, it doesn't matter. If I wanted these to spin relative to one another, I could have made an as-built revolute joint or something weird. Yeah. I showed you grounding to keep something from moving. You right click and say grounded. That way that component will not move. I suppose you could have grounded the upper and lower saddles and done the same thing as creating a rigid joint. We imported files from master car. We used step files, brought them in. Okay. Almost done. We got 15 minutes left. Okay. So the next question is, what happens when you want to make a little bit higher quality image than what you see on screen? That image there to the upper right is an actual rendering out of Fusion. You have to realize what's going on. It's just simply generating things that look like a real world object. Okay. In its basic form, what Fusion does all the time is rendering. The high end of the spectrum, you have special effects like you see on movies or whatever, where things look very much so real. Fusion hits somewhere kind of in between there. And it doesn't animate render, it just does still renders. It's a whole separate workspace, just like the draw was, or the drawing was. So if I want to make a pretty picture out of this thing, I'm going to say, let's render it. Assuming I'm happy with my materials, I'm fine with that. If not, I can go into appearance right here and say, well, I would like metallic paint. I really want that to be metallic blue instead of just a plain old blue. And that one should be a silver. Or whatever. If I wanted to make it out of water. Suppose you're trying to illustrate a swimming pool or a washing bath for vegetables or whatever. I could create a chunk and then come in and tell it, hey, that's water. So there are a lot of non-metallics that are available out there. Woods, right? Plastics. But I set my materials the way I want to have my materials set up. Next icon over is scene settings. It says, all right, where do you want to put this and what do you want it to look like? My environment has a bunch of different environments. A dry lake bed. And I grabbed it and I drug it out and I released it out here. You can actually see the reflection of the lake bed on the object now, but it didn't show up. Well, that's because in my settings, I told it I want the background to stay solid. If If I tell it I want the background to represent wherever I put it, if I want to spin my background around, I can use the roller wheel to make my object larger or smaller. I can drag the view cube to show the background, to change my angles. I can get everything set up the way that I like it. I can change the focal length of my lens. It's very aesthetic. There's not a good hard rule I can say, well, always do it exactly this. Use this lens with this. Depends on your object, what you're trying to show, what you want it to look like. But you get it the way you want it to look. If you want to go through and put a decal on something and you've got an image file, you can go in and add a decal. Once all that is said and done, I hit render. Fusion will say, all right, how big do you want it? It's a little bitty one because it's faster. It tells you it requires credits. If you're a commercial industry, you have to buy those. As students, you get an unlimited number of credits. So don't worry about if you went in and picked something that requires 8 credits. I'm not about to render something that big. It'll take forever. If I do it on the cloud, it'll render it out in the middle of Autodesk servers. If I do it locally, it'll render it here locally on my machine. I'm going to check cloud because my machine is about full. So I'm just, and say render. Fusion starts to buzz and whirl and think about it. And in however long it takes, it will come back and it will generate down at the bottom there a thumbnail of what this rendering should look like. How long do we have? 10 minutes. Hopefully it'll come back within 10 minutes. Because once it renders, then you can download that high quality image to your computer and import it or use it wherever. Appearances, decals, there's a cast iron thingy. I included this image as in my things that I sent to Young. So if you're interested in looking at that one, it's got a decal on it and what I sent. And there are some of the rendering galleries of that object. That's my basic presentation, all right? So we've got about 9 minutes left in class time. I'll be happy to field questions while we're sitting here watching this thing render, and hopefully it'll come back before we finish. If not, if there's anything you have to say, Colonel McGee, while we're sitting here watching this thing render its way out, we can take time and let you talk about whatever.
Now this is I want y'all to treat this as a resource because you've got this video that takes you step by step through creating some of these drawing objects, and you've got the slides that you can kind of keep at hand also to go through some of the steps. So together, this is a resource that you guys can really up your game in terms of your visual communication. This is something that y'all can work on over your really, really long December break. So I'm going to have a lot higher expectations in the spring of some of your communication via the drawings. So y'all practice this.
So we had someone ask about renewing your license. If nothing else, you can always uninstall and download a fresh copy and reinstall, and Autodesk should just pick up right there. You can also email back to support@autodesk.com and just say, hey, I'm a student at Texas A&M. Here's my license number or serial number or whatever. How do I reactivate? And they can reactivate for you. So
Remember,
we're just
this it's not just in if you're coming up with some kind of part, but a lot of you are going to use this as a, for example, think about how you would use that in your current project this semester, where you've got a system you're putting together. You could draw a more detailed schematic of how these things come together. I wouldn't expect every nut and bolt of this thing to be drawn out, but you can at least show your client how the cantaloupe sanitation system would work together. You could draw a conveyor belt with some cantaloupes on it, and some brushes and some sprayers and you know, a collection hopper at the end, or however your system works out. So you need to be able to accompany your narrative with some drawings to illustrate that.
And if you have questions, I don't know if Colonel McGee or Young has put my contact information. I'll be happy to get emails. Again, you should all probably have it because you're in my 105 class, but I have no objection to fielding questions over the break or next semester or whatever for what's going on. There is an Autodesk student rep on campus whose name just escaped me, but if you ask, I can get it for you. He was my grader for a year, and I forgot his name. Jules Bettner. He is a student representative from Autodesk, or works for Autodesk, who's an expert in all of this. He probably knows more than I do. And I can get you in touch with him if you've got more technical questions about things.
Okay, well, Yang, you make sure that Mr. Whiteacre's contact information is available to the students, and so that'll be a resource. And like I said, you guys use the month of December and that first part of January to get good at this, because this is a great tool that you can use for the rest of your career. And this is an excellent time for y'all to practice this. I can't tell you how many former students I've talked to that say when they hire a student, I wasn't so sure about this guy, but when he was able to draw some of the stuff, he just became the go-to guy in our company. Everybody brought him stuff, and his drawings just were able to knock our socks off. So that is a very marketable skill that is highly transferable no matter where you work, that y'all need to take advantage of this. So I appreciate you coming, Matt. And
you're welcome. The render just finished, so if I can take another minute or two, we'll look at how to use that, because it just finished rendering.
Good.
Once it renders, if you click on it, it'll open it up in a little window in the middle of the screen. And from here, you can download the image to your own computer, PNG, JPEG, whatever. If you don't want to see the background, you can make it a transparent background on the download. Usually you'll like to see it, but it'll just create an image on your computer. You know, whatever. And that saves it to your computer, and then you've got an image file. You can do whatever it is you need to do with it. If you needed a different view, you change your viewpoint around and you render it over again. So that's what I got.